Hey YouTube solar folks, this is Phil again. What I want to do today is show you what I've got in mind as far as hardware mounting is concerned inside the metal garage where I'm mounting my equipment. What I've got here is I've got the MagnaSign inverter, and the MagnaSign switch box, and a Midnight Solar charge controller. And we'll talk in more detail about each one of those pieces of equipment a little bit later, but today I wanted to focus on the hardware mounting. Where I plan to mount this hardware is on this board that's located about 8 inches out from the wall. It's a 5/8 inch plywood board painted with vertical 2x4s behind it that will be at the heavy load points where the equipment gets mounted. Since this MagnaSign inverter and all the equipment weighs about 100 pounds, the way I typically work one of these projects is I use cardboard, make a template out of cardboard, and then move the cardboard around and find an optimal location. And so right now, this is the location where I plan to mount the equipment. The MagnaSign inverter, I found out after reading the manual, puts out about 194 degrees of heat at certain times, and they say to absolutely not mount it on a wooden or painted surface. So what I've got here is I've got a piece of hardy board I have left over from a project that I did on the house. And my plan is to put a hardy board backing system up here underneath all of this cardboard, and that should be perfectly okay as far as not conducting the heat back into the painted wooden surface. Now, up above where the equipment is going, where this equipment is going, I've got a Midnight Solar switch box, our combiner box, and the combiner box is combining these cables here that are coming in from the photo cells outside, coming into the combiner box. And what I'm going to have to do, if you'll notice, there's a bus bar in here, and this bus bar handles 6 fuses, up to 6 fuses, 1/2 inch wide. Because my panels are putting out so much voltage, I'm going to change out this bus bar and put in a bus bar that will handle 3 1-inch wide 300 volt fuses. So this is one of the mistakes I made, and in your design, if you think this through carefully before you buy your combiner box, you can save about 1/3 of the cost of the combiner box, where you don't have to rebuy that equipment again. Now, as far as the batteries are concerned, my plan is to put the battery system right here, and see, I've got another template here, a cardboard template. The battery, the 48 volt battery system, will go here, and it's of course eight batteries, and because the end of the batteries, both positive and negative terminals, will be near the mounting equipment, it will be less than 5 feet to get the cabling from the positive and negative on the battery over to the inverter. By doing this, it minimizes the cable size that you have to use, but I'm going to go one size larger, like I've done on most of the entire project. I'm going one size larger on the cables in order to avoid as much voltage drop as I possibly can. Now, I haven't completely decided on it yet, but I'm looking at the possibility in designing a battery rack that hopefully will be movable. I'm looking at using these I-beams and putting wheels on them to carry that approximately 800 pounds of battery and move it around if I need to do it. So if I need to do some kind of maintenance or do some kind of work, then all I have to do is remove the cables that are going to the inverter and then roll the battery stand out of the way. Now, hopefully that will, cut down on the amount of physical labor that we have to do in the future. So anyway, this is the overall plan for mounting the hardware. I hope it's been of some interest or value to you, and we'll talk to you later.